All right. Hey guys, Nick here. In the last video, we went over the Lido V3 stVaults roles and permission structure, and we went through some of the top level roles, some of the roles that you can't really, the only role you can't change is the node operator role, and then the owners, the default admins, and all of the delegatable permissions that we can configure within an stVault system. This leaves a lot of different variations in terms of how we can configure our vaults, integrate our vaults into wider protocols and products, and exposes some really exciting things that I think we're going to see built in the near future. In this video, I want to go ahead and step through how to actually create an stVault. So we're going to look at it from a couple of different angles. We're going to use a bunch of different tools. Being that this is a smart contract protocol, it's going to be available on chain. We can build our own systems on top of the protocol to be able to create our own products. So I want to go ahead and walk you through 3 different ways in which we can create stVaults. Now, before we do that, I just want to, I'm here on the documentation center again within the stVault documentation center. And there's a bunch of information here about some of the tools that Lido have built around creating vaults. So the first aspect that I'd like to dive into is the web UI that Lido has put together for creating vaults. So this is available right here in the documentation center, right at the root level. If you scroll down here, you have the stVault resources, and there's some tools here. And the first one I want to look at is really this web UI. So I'm going to go ahead and pop into this web UI here. Now, this web UI is going to show you any vaults that you have created already, so you can see them here. And then you can see all of the vaults in the system right here. So you can see all of these vaults. Now I'm looking at Hoodie. So this is the test net. This is all of the different vaults that are on the test net. And they make it super easy to be able to come in here and just create a new vault. So there's a big button here that just allows you to create a new vault. And now you'll notice that these fields really match exactly what we outlined in the roles and permissions video that we did, where at the top level, we have our node operator address. This is that operator address that cannot change. And this is the address that will be registered with the operator grid as part of the overall Lido protocol. So this is the address that, as you go through the process, you become a registered known operator and your reserve limits can be changed. By default, when you're not a known operator, you have a 50% reserve ratio, which means that any amount of ETH that goes into the vault, you'll be able to mint up to 50% of that value. So if you put 100 ETH in, you'll be able to get access to 50 stETH. Now, those ratios will change as you become a known operator and you operate to the system. LIBC is happy to be a known operator, and we do have some higher reserve ratios there as a result. So our node operator address would go in here. The node operator manager and the vault owner, those are those 2 top level roles that we went over that allows you to delegate a bunch of other permissions out. There could be multiple addresses in each one of these roles. And then all of the sub roles could branch out from underneath that. But when we're creating an stVault, we initially create these 3 core addresses. So the node operator manager, and the vault owner. Now I'm going to go ahead and fill these in with just my test wallet I have here, which I'll copy the address here and paste it in here. All right, so we can have all of these in here. Now the next piece is the node operator fee. So this is the fee that the node operator is going to charge for running the node. So this is, we have to run software in our data center to be able to generate that yield. And we do enjoy getting paid for those services. So we could put in a fee here, say like a 10% fee. And then we can have this confirmation lifetime. This is the time it takes for us to be able to basically wait for confirmation for certain proposals that we can put forward. For example, when we want to change that node operator fee, if we negotiate a different rate with the vault owner, we can go ahead and propose a new fee, and there'll be 24 hours in which they can actually approve or deny that. So this is really kind of a timeout period. It's a good security feature to have in the protocol, and it defaults to 36 hours. Now, when you first create a stVault, it does require you to put a 1 ETH bond against the vault. So this is a required amount, and this is locked for the longevity of the operation of the actual vault. So you're going to put an ETH in here, and this is basically just a bond against your vault. Now, you'll go here and you'll confirm the fee structures and things like that, which we do need to dive into some of those fee structures, and we're going to do that in another video. There are a bunch of different fees as opposed, not just the node operator fee, but just to kind of quickly outline it, that there's the node operator fee, there's the typical just Lido fee for minting stETH. So stETH itself has an embedded fee within it for getting that liquidity. And then there's an infrastructure fee that is charged. It's a lower fee that's charged against just the unminted stETH that's sitting in the vault. So there's kind of, was that 3 or 4 different fee structures there. And the flexibility is really just like the roll system. The flexibility of how we can craft those fees are, I think, come into play a lot when we're starting to build different types of products around the stVault. So super interesting stuff in the fee structure that warrants a whole other discussion. Now, what we have to do here is confirm that and continue, and it's going to give us a little overview of what we've done, and we can go ahead and create the vault. And this is going to go ahead and kick off a transaction to do it. Now, I'm not going to actually confirm this one. This will go ahead and create it. But I think the important part of this is that when we do this, there's actually 2 smart contracts that get created. There's a dashboard contract, and then there's the actual vault contract itself. The dashboard contract is really the I would call it kind of like the user interface into your stVault. This contains things like exposure to be able to set and remove roles, be able to read, the status information around your vault. And it's truly kind of the interface into operating your vault. The vault itself, on the other hand, is more responsible for doing things like making deposits and interfacing with the pre-deposit guarantee contracts and holding the value of the stVaults. So you have really these 2 core components that kind of play together in order to create this idea of an stVault. You have your dashboard and your vault. So we'll go ahead and take a look at that in a minute, but I'm going to cancel out of this and we'll come out of this. Now, I'm not going to go to the technical side yet to get too technical. I do want to show off the command line interface. But before we do that, I just want to give you an example of what's possible with this, with building your own types of interfaces. So at LIBC, we actually built a very similar interface to what Lido built against the protocol. So if we pop over to libc.fi and we go /app/myvaults, we could see all of the different test vaults that I have here. I'm already connected with my test wallet, and I am on a Hoodie testnet. So you can see here that I do have a couple of different vaults created. This vault is rocking and rolling right now. We have a bunch of test ETH in it. We do have some validators against it. So you can see that we get some visibility into what's possible here, how much stETH we can actually mint. This particular vault's at a 50% reserve ratio. And you can see all the different roles and permissions associated with this given vault. We have a bunch of different funders for this one. We have one vault owner. We have a minter here that can mint, and a node operator manager. Now, if there's no addresses assigned here, that just basically means that the default admin, the vault owner, has access to those features, and they're not delegated at all. You could also see some of the advanced features here, and we'll get into this later when we talk about deposits, but we can do our deposits into the vault, and this will also outline those different fee structures, right? So these different fee rates and all the different accrued fees. You can also see the contract addresses here. So like I just said, there's the dashboard contract and the vault contract. These 2 contracts play together to be able to provide the overall system. And then there is something of an oracle here that keeps track of what's inside of the vault. And this reports back to the overall Lido protocol in order to keep track of the total value of the vault and how it's collateralized in terms of how much stETH is minted and things like that. Each time we do a vault operation, we typically update our Oracle report. And right now, we're doing that through the command line interface. This is kind of just an example of something that you can build. We've built it here at LIBC, and we also have a create vault interface. So you can go here and create your private vault. Now, this is typically something we would do for our clients. It's not necessarily a client-facing interface here. We would come in here and you could do exactly what you saw on the Lido side, where you can set the vault owner, you could set the node operator address, the node operator manager, the operator fee, the confirmation window, the connection deposit, and then take you through and see the summary here. And then you could go ahead and deploy your vault, and it'll do the same exact thing. It's communicating with the same factory contracts on the blockchain, and it'll go ahead and create those two dashboard and vault contracts for you. So pretty easy. We have some pretty simple user interfaces to be able to do this. And I'm sure these user interfaces, as time goes on, are going to evolve and change as we build products on top of this. So super exciting time. And those are just two examples of really simple ways to create stVaults. Now, what I want to do is I want to shift gears a little bit and get a little more technical. Lido is putting a lot of energy into their command line interface, which I personally find really exciting. There's a lot of really cool tools that you can do with this interface. So I want to go ahead and take a moment and just get a little bit more technical and show you how to set up the command line interface and see and peer into some of the information around a given vault. So let's go ahead. I'm going to flip over here to my command line, and I have, this is the Lido Staking Vault GitHub right here. So let's go ahead and click that here and we can take a look at this. So this is a project that Lido put out, the Staking Vault CLI, and the velocity on this is pretty cool. These guys are doing a great job where we're seeing a lot of new features pushed to this. They have some good documentation here about how to actually set this up. But what I'm going to do is I'm going to start fresh here. I'm going to go ahead and clone this down into my machine here, and let's get right into the project. So first thing I want to do is I want to set up my environment where I'm going to copy the .env for all of the environment variables. And let's go ahead and just edit this. So we're going to run this on Hoodie. So it's already configured with the Hoodie vaults. This basically just contains all of the contract addresses that exist or are deployed to the Hoodie testnet. This is the private key that you could put in here for vault operations if you want to do like signing stuff. I wouldn't recommend doing that. I mean, you don't, unless you're just testnetting this, and maybe we can go into some of that where we just testnet it and I just post a, throw out private key up here. But one cool feature this has, if you want to sign it and be a little bit more secure, you can actually do this where you have a wallet connect project ID. And this is kind of cool where you can use Wallet Connect to sign your transactions. All you would need is a Wallet Connect project ID to do this. And you can easily get that through Wallet Connect here. And I think I have a project set up for this already. I do. So I have an app ID here already. I think, yeah, project ID. Boom. Grab the project ID. Then we could just throw this right in here. Oops. And boom. Now it's using Wallet Connect to sign transactions. Now, you do want to have access to a consensus layer client and an execution layer client to be able to do your stuff. You can use Alchemy to do this, or Infura or something like that, like a hosted RPC. At LIBC, we do run our own nodes. So I do have access to our node here. And again, this is all on testnet. So we're going to go ahead and connect to both our execution layer and our consensus layer nodes. Awesome. Okay. That should be set up. Now, the only other thing we need to do is do a yarn install, because we have to install all of our dependencies. Now, some of you watching this may be like, hey, why would I do this when I just, have that really slick web form to be able to create these? And you're right. You probably, for creating vaults, you probably want to use more of a UI, but there are a lot of features here in the CLI that are not yet available in the UI. It's worth kind of taking a peek at what's possible here. So now with everything there, the dependencies downloaded in your .env file there, we can go ahead and just hit yarn start help. And boom, there we go. So we're connected to Hoodie. We have the chain ID here, and it'll give you all of the different options that we have here. Now, for example, if we wanted to see an index of all of the stVaults that are deployed to Hoodie, what we can do is we can say yarn start contracts -v-v are all And this will go out and read all of the stVaults that are on the network. So you can see right now we have 435 stVaults deployed to the network. And these are all of them. Awesome. Now let's do something a little bit more interesting. Let's take a look at one of our vaults here. So I'm going to go ahead and let's grab the dashboard address here. I'm going to say yarn start help. Let's explore some of the help documentation here and some of the things that are possible. This is kind of one of the ways to kind of just explore what's possible here. So you can see at the top level, we have contracts, DeFi wrapper, which I really want to get into. I'd like to do some content around that. Account, vault operations, reports, consolidations, and etc. Look at some of the additional vault operations that we can do here. So let's go VO, the help, and let's see what's underneath that option. Awesome. Now, each one of these sections typically have a read and a write section. So the read section is really what we're gonna dive into. We're not going to be signing any transactions. We just want to go ahead and get some info. So awesome. So let's look at read and let's look at overview. Let's see what we need to do here. I'm curious how we would connect Wallet Connect to this. So we have a Wallet Connect ID. I'd like to be able to connect this wallet to this environment through Wallet Connect. Okay, so we have some really interesting possibilities for being able to connect to wallets using the CLI. The biggest is Wallet Connect. So if you're working in mainnet, you're most likely going to be using a multi-sig, like a safe multi-sig, to be able to do operations against your vault. Now, if you're doing anything on the CLI, you're going to want to use Wallet Connect to access that. So how do we do that? On the CLI, all you have to do is pass this Wallet Connect flag here for any operation that you're doing. And if you'd enter here, it's going to show you a big barcode or a URL here, and you can feed this into your safe interface to be able to connect to this. Now, we're not on mainnet right now, so this is not going to work for us, and safe isn't really deployed too well on Hoodie. There are ways to do it without a UI on Hoodie. I think there are some contracts out there, but we're not going to be able to demonstrate it here too clearly. So I'm going to leave this as is. This is kind of really cool, and I'd like to explore this a little bit more. But what I did do was I did load up a private key in that file on Hoodie so that we can actually see what this looks like. So if I take this off now, I do have that private key loaded in the environment file, the .env file. And now we can see here when I do pass that in there, I'm just doing a vault operations read info, and it's going to show you the vaults that you have available. And I'm going to go ahead and select this first one. And now, anytime you're doing any vault operations, it's going to ask you, hey, do you want to submit a new report immediately? This is going to be an updated Oracle report that will update the protocol on the state of your stVault. You can say no here. I'm going to say yes. I'm going to go ahead and submit a fresh report. And we'll say yes again. Let's go ahead and submit that. That's submitting to Hoodie, it's updating and submitting a fresh vault, the vault update to the Oracle. So we're calling this update vault data method on the protocol. Okay, awesome. Once that's done, we're going to get all of the information back about our vault. So you can see a lot of the information that we display in the user interface is also available here. It gives you really detailed information about the vault. So awesome. So that is basically the command line in like a quick nutshell, right? There's a lot of different things that we could do with the command line interface. And I want to get back to the CLI here and some of the documentation that we have here. So it outlines a lot of this stuff. I want to try this one. Let's try the count all vaults, because we listed all vaults before. This looks like it'll just count them all. So let's see, contract hub R v counts. No, it's not dash R, it's just R. Awesome. There you go. 435. Excellent. Excellent. And you could, of course, go through and you can actually create stVaults using this interface as well. There is a way to do that. So it will basically take you through and pass in all that information. You could also do things like prove a validator exists on chain. And I think that from our perspective right now is very useful, because going through and doing that whole Merkle proof piece can be pretty hairy, and this is already developed and it's ready to go. So you can use that to prove validators. Makes it super easy. So we're going to get into some more of that as we progress through this. What I do want to do is go ahead and actually create a new stVault with you. So I'm going to go ahead, I'm going to use the LIBC interface here. And we're going to just go ahead and create a new vault. We'll say the operator fee is 5%. We're going to use all of these addresses here. And this is fine. This is good. Super easy. And let's deploy this bad boy. Okay, excellent. This should have 1 ETH. And we'll go ahead and confirm that. And this should create a new vault for us. Now, right now, if I go ahead and do this, all right, looks like it was confirmed. Beautiful. We have a vault. Excellent. And now we should see, oh, I have these hard-coded right now in this, so it's not going to come up here, but we should see it come up here. Beautiful. There we go. Now we have 4 vaults, and they're good to go. Excellent. So in the next video, what we're going to do is we're going to work with this vault, this newly created vault, and we're going to work through funding the vault and then going through and actually doing a pre-deposit so that we can start to create our validators. We're going to take you through the whole cycle here. All right. So any questions, comments, please leave them below. And we look forward to continuing to build with y'all. Thanks.